In this video, we're going to prove the product rule. So I'm starting off by letting p of x be f of x times g of x, and we're going to find the derivative of p of x using the definition of derivative. And we're going to assume that f and g are two functions which are differentiable themselves. Alright, so to find p prime of x, what we need is the limit as delta x tends to 0 of p of x plus delta x minus p of x over delta x. Alright, now what does all this mean? Well, p of x is defined in terms of f of x and g of x. So this is going to be the limit as delta x tends to 0 of f of x plus delta x times g of x plus delta x minus f of x g of x all over delta x. Alright, so that's just using this is just the definition of derivative, and this we get by substituting in f of x times g of x for p of x. Now for this next part, I'm going to do something that is a bit unexpected perhaps, but it's actually a fairly common technique in mathematics. We need a term. We need f of x plus delta x g of x. So I put it in there because we need it. But I've got to pay for it. So I'm going to put a plus f of x plus delta x g of x in as well, all in the denominator. And probably the thing that alarms you the most, pardon me, is the fact that I put this in there anyway, and that I knew that I needed it. Well, I've seen this proof many times before, and so I know what's needed. And you will see that everything will turn out right. My guess is that you're not alarmed by the fact that if I subtracted this off, that I also added it in. Alright, so let's continue. Notice that there is a common factor of f of x plus delta x in these two terms, and there's a common factor of g of x in these two terms. I'm going to make use of that. I'm going to take those out as common factors. So when I take out the f of x plus delta x here and here, that'll leave a g of x plus delta x and a minus g of x behind. And I'm going to put all of that over delta x. And then I'm going to work with this separately. And actually, here's what I'm going to do. I'm going to do something a little bit more. I'm going to break this up into two pieces. So I'm going to take the limit of the first two and the limit of the second two terms. So taking out the common factor of g of x, That's going to leave f of x plus delta x minus f of x, and that's all over delta x. All right, so we're about halfway done, I think. I'm going to do some rewriting. I'm going to write this as f of x plus delta x, and then I'm going to only put this part over delta x. It is algebraically equivalent to what we started with, or to what we have up here. Now, here's something else that you might not have seen before and might not have thought of. This is a limit of delta x. Delta x is what's tending to 0. This g of x does not depend on delta x. So as far as delta x is concerned, g of x is a constant. So I'm going to treat it like one. I'm going to pull it out front. Now, I hope that some of this is starting to look familiar. This part in particular, the limit as delta x tends to 0 of f of x plus delta x minus f of x all over delta x, that is the definition of f prime. So I'm going to replace that with f prime of x. That looks like part of what we need. Alright, now, as delta x tends to 0, what's going to happen here is that this delta x is just going to go away, and this is going to leave us an f of x. Now, the limit of this part, as delta x tends to 0, that's the definition of g prime of x. And so we have f of x times g prime of x plus g of x times f prime of x. The proof is completed.